when you are converting between different substances that are in the same chemical equation, you always need to convert to moles before converting to anything else. So first, we go to moles. And no matter what, you will always be starting with some piece of what I will call the given information. So if we look at number 1 that's beneath this, it says determine the mass of NaCl produced when 1.25 moles of chlorine gas reacts with sodium. So in this case, this is my given information. So I am given 1.25 moles of chlorine gas. So I'm going to refer to chlorine gas, or just chlorine in this case, as my given substance. So if I put this on my mole map, I'm going to say your starting substance is going to be your given substance. So as I just pointed out down here, what I mean by given substance is just whatever chemical compound it is that you are starting with. It could be a single element like sodium in this case. It could have been NaCl, but in this specific question, it happened to be Cl2. So my given substance is chlorine. And then the other substance that you're going to have is going to be, we can call it the unknown substance or maybe the question substance. So substance that the question is asking about. And so I'm using 2 different colors to kind of take us through this. So if we are talking about the substance that the question is asking about, sorry, that's a terrible line. That will be there. And if we are in our given substance, which is always where we will start, we will be here. So typically when I do this, I will start in grams, because from grams, there is only one place you can go. So this doesn't necessarily mean that your given has been given to you in grams. It just means, I think that's an easy way to start our problem. So a lot of the questions do start in grams. That would be mass. From grams, you can go to moles, still of your same substance, the given substance, and then from there, we have what we call particles, and so this can either be atoms or it can be molecules or it can be formula units. So grams is one destination, moles is another destination, and then each one of these would be their own, but the conversion factor between any of these representative particles is the same. So this kind of goes along with page 1 of our notes that we reviewed last class period. And then I'm going to mirror that exact same thing. I'm going to put all of those same things down in the substance that the question is asking about. So grams is going to be one thing, moles is going to be another thing, and then I'm going to have atoms or molecules or formula units. So atoms. Sorry? Formula units. So the abbreviations for these, you have them on your periodic tables probably, but remember that molecules we represent as MC, and then formula units we call FUN, and then I'll do the same thing up here. Molecules we call MC, formula units FUN. So if those look familiar, that's what they stand for. So the way that I like to use this mole map, make it thin again, is starting always with your given substance. You will either be given information in grams or moles or one of these things. So in this case, we are in moles. So we still start in our given substance, but we would be starting in this box right here. For grams to convert to moles or moles to convert to grams, that conversion factor is called molar mass. So I'm going to write molar mass on this line. And molar mass is always 1 mole. So every single time you are doing molar mass, by definition, molar mass is 1 mole. So in your T-chart, next to moles, when you're doing molar mass, the number is going to be 1. But next to grams, that's where we need to look up the actual molar mass on our periodic table. So the number for grams, I'm going to say, comes from, I don't know where to make this like the most clear that I'm talking specifically about grams. So grams comes from F-R-O-M, from PT, for periodic table. So the number that will go in front of the unit grams will always come from your periodic table, and the number that goes in front of moles, specifically for molar mass, this conversion right here, will always be 1. And then this little pathway underneath it, if you are talking about a different substance, or if there's a substance in question, it's the exact same thing. It would just be a different value because it's a different formula that you're answering this for. So this is still molar mass. It is still always 1 mole. And your number of grams still comes from where? Good. So that is our conversion from grams to moles. So if this looks familiar, again, this is something that we spent a lot of time on during first semester, but it has been quite a while since we did that. Then we can go from moles into either atoms or molecules or formula units, and the conversion factor for any of them is going to be the same. So this pathway right here, this is where we use Avogadro's number. Make it thicker. Avogadro's number, remember, is that 1, that was way too thick, sorry. I wanted it to stand out, but not that much. Give me a second. Maybe like that. So 1 mole, there we go, is equal to 6.02 times 10 to the 23rd of any of those things. So 1 mole equals 6.02 times 10 to the 23rd atoms, 1 mole equals 6.02 times 10 to the 23rd molecules, or 1 mole equals 6.02 times 10 to the 23rd formula units. All of those are true, and then if you're determining which one you're going to, it just depends on the specific substance. So for example, down here for Cl2, chlorine with Cl2 is a molecule. So if I did need to convert this, that's not what the question is asking for, but if I were converting it to particles, I would convert it to molecules because Cl2 is a molecule. But sodium is a single element, which is an atom, so this one would turn into atoms. And then this one is a formula unit. So actually I have all 3 represented in this one question. So this is an atom, this is a molecule, and this is a formula unit. So that is how you would determine which one you were going to. It's just basically about the right vocabulary depending on the substance you're talking about. And then again, these down here on the second substance are all the same thing as we wrote above. So I'm going to make a thin line again to say we can go from moles into atoms or atoms into moles. So notice that all of the arrows that I'm drawing are double-sided. They go both ways because you can convert back and forth between the 2 of these. And then again, 1 mole is equal to 6.02 times 10 to the 23rd of each of those. That's kind of rough looking, but hopefully you get it from above. It matches. It's the same thing.
So you would either have to times it or divide it?
Correct. You would either multiply it or divide it depending on which way you're going. And so that's what we use our T-chart to help us set up. So if you bring down your units to cancel every single time, then that will already be done for you. So what we're adding on in this unit, because we have had this mole map before, what we're adding on now is finally a way to get between 2 different substances. So we can go from moles of one thing into moles of another thing. The only place where these 2 lines can connect is from moles to moles. So that is what we've been practicing for the past day and a half, is writing what we call mole ratios. So I'm going to make this thinner. So I'm zooming way in. If you drew yours super close, as long as you can tell that it's supposed to go on this, I'm going to write sideways. But if you have not enough room to write on this, that's fine if you write that way. So I'm going to say mole ratio. Put it in black so it stands out on here. So mole ratio. And the mole ratio comes from the coefficients in your balanced chemical equation. So if I zoom that out, this is your whole mole map. So to get between two different substances, you have to use a mole ratio that comes from the coefficients in your balanced chemical equation. So let's do example number 1 so that you can see how we actually use this in practice. So in this one, example 1 says, use gray. Determine the mass of NaCl produced, which means that my final answer is going to say something grams of NaCl, since that is what the question is asking for. So the substance that the question is asking about is NaCl. And it says when 1.25 moles of chlorine gas reacts with sodium. So I'm going to start with my given information. I'll use a different color for this one. Let's do like pink. So my given substance in this case is NaCl. Not NaCl, sorry. Chlorine gas, Cl2. So my given 1.25 moles of Cl2. To make sure this is balanced. My chlorines, I have 2 on my reactant side, so I'm going to need 2 on my product side, so a coefficient of 2 here. That also gives me 2 sodiums, so I need a coefficient of 2 here, and then just a 1 right there. So some of these are going to be super easy to balance, some of them not so much. So if I start in my given substance of Cl2, my goal is to get to the other substance. I'm starting in moles of my given. So instead of starting here, I'm actually skipping a step and starting here because my given was given to me in moles already. So I have 1.25 moles of chlorine. From moles of chlorine, there are a whole lot of different places that I can go. I can go to grams of chlorine, I can go to atoms, or molecules, or formula units of chlorine. We already said it'd be molecules because chlorine is a molecule. Or if I want information on a different substance, I can go down into moles of that second substance. So I'm going to bring down my unit of moles of Cl2 so that this cancels out. So if you remember to bring down your units every time, it will help you set this up in the right way of when you're multiplying versus when you're dividing. So I bring that down so that it will cancel, and what that means is that now I can go from moles of chlorine into something else. So if I'm starting in moles of chlorine, what I want to do is go into moles of my second substance. So my second substance in this case is NaCl. So I'm going to go to moles of NaCl. So now I'm here in my second substance, the one that the question is asking about, NaCl. So here, now I can go either back to moles, or I can go to grams of NaCl, or I can go to atoms of NaCl if that's what the question is asking for. Again, since I have my unit up here, where do I know I need to put it next? Diagonal down so that it cancels out. So moles of NaCl comes to the bottom. Those two are then going to cancel, and then I'm free to convert this into something else. So I can go from moles of NaCl into grams of NaCl. And then the things that we wrote on the line, on the path between each of these, tells us what our conversion factor is when you go from one thing to the next. So I'm going to just use black so I don't have to keep switching colors here. between moles of Cl2 and moles of NaCl, that was this path right here, moles to moles. If I'm going from moles of one thing into moles of another thing, hard to read now, but we said you use the coefficients, which comes from my balanced chemical equation. So I need to look at my substances in the equation. I have 2 moles of NaCl for every 1 mole of Cl2. And then between grams and moles of NaCl, so notice I'm going grams to moles of the substance that it's asking about, it's going to be molar mass as my ratio. Molar mass is always 1 mole, so I'm going to put a 1 right here. And next to grams, that number comes from the periodic table. So I would look that up here, where sodium is 22.990 and chlorine is 35.45. So I would add those two together. 22.990 plus 35.45. I'm going to use a calculator. What'd you get? 0.44. Do we agree with them? I think so. Anyone got something different? I trust them. All right. So then to calculate this, I would multiply everything on top and then divide by everything on bottom. But if you remember, having ones anywhere in this doesn't change your answer at all, since multiplying or dividing by 1 will not change anything. So 1.25 times 2 times 58.44. And that gave me 146.1 grams. My pen stopped working. Okay, 146.1. And then just to be transparent about the grading on a question like this, remember that I will always give you points for everything that you're showing me. So in this question, I would give you a point for your number, a point for this unit, including your substance, a point for the number, a point for the unit, including substance, point for the number, a point for the unit, including the substance, number, unit, including the substance. This one, I would actually give you 2 points for calculating molar mass, since you could have maybe understood that molar mass goes there, but maybe you made an adding mistake or something. And then a point for your unit, including your substance. Oopsies. And then a point for your final answer and a point for your unit, including your substance. So that is 2, 4, 6, 8, 10, 11, 12, 13 points for a question like this.